In this video, we are going to take a look at some basic circuit configurations and explore how to use a voltmeter and ammeter to measure the circuit voltage and current. Before we build the circuits, let's look at the components and devices we will be using, understand how they work, and see how they are represented in circuit diagrams. Here you can see four cells joined together to form a battery. This battery provides a voltage source for our circuit and has the following symbol when drawn. The long line represents the positive terminal and the short line represents the negative terminal. Electrons actually flow round the circuit from the negative terminal of a battery to its positive terminal, but conventional circuit diagrams show current flowing from the positive to negative terminals. In order for an electric current to flow in a circuit, there must be a voltage source and a closed path for free electrons to move. Electrons are only free to move if the materials being used are conductors, such as copper wires. Copper wires with crocodile clips on the end are called jumper wires, and what we will be using to connect our battery to the rest of the circuit. Simple copper wires, called leads, are what connect our components to each other within the circuit. They are insulated to prevent us from being shocked and also to prevent shorts when touching other components in the circuit. Leads are drawn as straight lines in a diagram. There are two ways to connect components to each other. One way is to solder everything together. The other is to use a breadboard, which is what we will do. Let's look at how the mini breadboard we are using works. You can see here there are 17 rows of 5 holes on the left, separated by a gap of 17 rows of 5 holes on the right. Each of the 5 holes in one row are connected underneath by a metal strip. This means that you cannot place a single component like a resistor in a single row, as current will take the path of least resistance. Thus, bypassing the resistor, a component has to be straddled across 2 rows to ensure that current flows through it. Here is a resistor, which is a component that reduces the flow of current. We use it in our circuit to reduce the current entering the adjacent LED diode. As diodes are current sensitive, the size of the resistor depends on the color of the LED, as each color has different specifications. A resistor has the following symbol. A diode is an electronic component that allows current to pass through in one direction but not the other. So, because electrons flow in only one direction to create current, it is important to place the diode the right way round in a circuit for it to work. The long leg, or anode, faces the positive terminal side of the circuit, and the short leg, or cathode, faces the negative terminal side. A diode is represented by this symbol, and we add this to the symbol if it is a light-emitting diode or LED. An ammeter, represented by this symbol in a circuit, measures the size of the current in the circuit or the rate of flow of electrons. A voltmeter, represented by this symbol in a circuit, measures the potential difference, voltage drop in other words, across 2 points in a circuit, or how strongly the electrons are being pushed through the circuit. In our videos, we will use a multimeter, which is an ammeter and a voltmeter in one.